In the realm of artificial intelligence and robotics, the development of smart autonomous agents has garnered significant attention in recent years. These agents are designed to interact with their surroundings, including other agents or humans, through natural language. This paper introduces a novel computational model called UNMuTe, which consists of two main components: a dialogue model and a navigator. The dialogue model is based on a GPT-2 decoder that handles multimodal data consisting of both text and images, while the navigator is a modified version of Duet, a VLN model that has been adapted to receive dialogue as input and has been equipped with a policy to decide when to generate dialogues. The proposed model aims to address the limitations of traditional vision and language navigation (VLN) tasks, which require an agent to interpret human instructions given at the beginning of each episode and navigate accordingly. However, this setup can lead to the agent diverging from the correct trajectory when the match between the instruction and visual cues is unclear. To overcome this, the authors extend the VLN task by allowing the agent to generate conversations with an oracle, asking for new instructions to redirect it in the correct direction to the goal. The dialogue part of the model is trained to generate question-answer pairs conditioned on the target object and the current position of the agent. A decision mechanism is also introduced to regulate the generation of dialogue, based on the confidence of the navigator. When the navigator is unsure of which direction it should take, it should ask the oracle for help. The authors compared different dialogue activation policies, studying the effect of dialogue generation on navigation. The experimental analysis proves the effectiveness of the proposed model, achieving state-of-the-art performance on the main navigation tasks implying dialogue, such as cooperative vision and dialogue navigation, CVDN, and navigation from dialogue history, NDH. The paper also discusses related work in the field of VLN, including various approaches and datasets like StreetLearn, Touchdown, and Talk the Walk, which involve human annotated dialogues for navigation. This research proposes a novel computational model, UNMuTe, for visually grounded dialogue navigation. UNMuTe consists of a navigation model and a dialogue model that generates question and answer pairs to guide the navigation agent. The dialogue model is a single generative pre-trained transformer, GPT-2, that generates question and answer pairs conditioned on the trajectory to the target object. The model is fine-tuned to achieve multimodal capabilities using the trajectories and conversations contained in the CVDN dataset. The navigation model is a modified variant of dual-scale graph transformer, Duet, that keeps track of visited and observed nodes by producing a topological map of the environment. The model is modified to account for backtracking behavior in human-generated trajectories. The prediction of the next location considers an action space comprising all possible navigable nodes in the graph, including a stop action. The dialogue model generates question and answer pairs when the trajectory to the target is not clear. The confidence of the navigator is quantified as the entropy of its action probability distribution, and when the entropy exceeds a threshold value, the navigator triggers the dialogue model. The conversation returned by the dialogue pair is concatenated to the input of the navigator to recompute the probability distribution over the action space. The proposed model is evaluated on the CVDN and NDH datasets, which consist of human-human dialogues in simulated indoor environments. The results show that the model improves the performance of navigation agents on several VLN datasets. The use of a learnable parameter as a threshold for triggering the dialogue model is also evaluated, and the results show that it outperforms a fixed threshold. The key contributions of this research are the proposal of a purely generative speaker model that produces elaborated conversations with detailed answers, and the integration of a dialogue model with a navigation model to improve the performance of navigation agents. The results demonstrate the effectiveness of the proposed model in visually grounded dialogue navigation tasks. The UNMuTe model is a vision and dialogue navigation (VDN) approach that leverages a dialogue model to generate question and answer pairs to guide navigation towards a target. Trained on the CVDN and NDH datasets, the model consists of a navigation module and a dialogue model, with the latter using a pre-trained GPT-2 decoder. The navigation model uses ResNet 152 features and has 164 parameters. Experimental results show that UNMuTe achieves state-of-the-art performance on the CVDN dataset, with a goal progress of 13.35 meters and a success rate of 7.73. The model outperforms recent methods on the CVDN and NDH datasets, including RMM, SCOA, HAMT, and VISITRON, in terms of goal progress, success rate, and normalized dynamic time warping, NDTW. An ablation study evaluates the effect of different prompt embedding sizes on navigation performance, showing that using 4 learnable prompt embeddings achieves the best performance. The model is also evaluated using different image feature extractors, with ResNet 152 features achieving the best performance. On the NDH task, UNMuTe achieves state-of-the-art results, outperforming competitors in navigation metrics. The model's ability to generate high-quality question and answer pairs is evaluated using NLP and reference-based description metrics, showing that UNMuTe's dialogue model is better at generating correct answers than asking proper questions. The model's effectiveness is further demonstrated by its ability to incorporate future images and target objects as conditioning signals for answer generation. Qualitative examples of generated dialogues showcase the model's ability to generate coherent and accurate question and answer pairs, correcting mistakes in ground truth answer annotations and providing accurate instructions for navigation. The model is trained on a dataset of navigation episodes using dialogue instances as textual input and evaluated on the val unseen and test unseen splits of the NDH dataset, achieving top 1 performance on all metrics. The paper introduces a novel computational model, UNMuTe, which integrates dialogue and navigation in an environment. This architecture consists of a dialogue model, utilizing a fine-tuned GPT-2 decoder to generate synthetic dialogues, and a navigator model, based on the Duet model, predicting navigation using both ground truth annotation and generated dialogues. The model learns to navigate more efficiently by employing an entropy-based, whether to ask, policy that predicts when it is beneficial to generate new dialogues, achieving state-of-the-art performance on vision and language navigation, VDN, datasets. The authors emphasize the importance of learning from in-labeled 3D environments for vision and language navigation, as well as leveraging image-text pairs from the web to improve navigation. They highlight the role of embodied AI research platforms, such as Habitat, in facilitating the development of such models. Furthermore, they emphasize the need for multimodal attention networks and history-aware multimodal transformers for low-level vision and language navigation tasks. The paper also explores the use of pre-trained language models, like BERT, and their ability to learn transferable visual models from natural language supervision. It emphasizes the significance of learning to navigate in cities without a map and the potential of using human-in-the-loop methodologies to assess the effectiveness of these models. The paper concludes by discussing future work, including the exploration of object-based interaction and the development of a generic agent for vision and language navigation. In the realm of vision and language navigation, researchers have been exploring various approaches to enhance the capabilities of embodied agents. This includes the use of multimodal text style transfer, as proposed by Zhu et al. 2020a. Which aims to adapt the linguistic style of navigation instructions to better align with the visual context, improving the agent's ability to understand and execute commands. Wang et al. 2019 introduced Gibson ENV, a real-world perception dataset designed for embodied agents, providing a comprehensive platform for training and evaluating models in realistic environments. The concept of cross-modal memory has also been explored in this domain. Zhu et al. 2020b proposed a vision dialogue navigation model that utilizes cross-modal memory to improve the agent's understanding of its environment. By leveraging both visual and linguistic information, the model can better comprehend complex instructions and navigate accordingly. Moreover, researchers have developed evaluation metrics to assess the effectiveness of these models. Vedantam et al. 2015 introduced CIDR, a consensus-based image description evaluation metric that measures the similarity between generated and ground truth descriptions. This metric has become a standard tool in the field for evaluating the quality of generated text. In addition to these advancements, there is ongoing work on improving the efficiency and adaptability of vision and language navigation models. For instance, Zheng et al. 2023 proposed ES-SEME, a model that utilizes episodic scene memory to enhance navigation capabilities. This approach allows the agent to remember and recall relevant scenes during navigation, thereby improving its performance in complex environments. Overall, the field of vision and language navigation continues to evolve with new methodologies and datasets being developed to enhance the capabilities of embodied agents. These advancements are crucial for creating more efficient and adaptable models that can effectively integrate visual and linguistic information for successful navigation tasks.